Hello, this talk will introduce our Multimodal 3D Surface Super Resolution Network, MNSRNet. Recently, 3D data is widely used in various applications such as architectural survey, autonomous driving, film and television production, digital entertainment, cultural relics protection and topographic survey. For cost reasons, people always want to get high-quality 3D data from low-cost 3D acquisition results. This has led to the study of 3D surface super resolution to improve the quality of existing 3D surfaces. There are a lot of studies about 3D surface super resolution. Mesh-based methods have been studied for many years based on mesh subdivision and vertex interpolation. Nevertheless, these methods tend to generate blurry results. Point cloud is the most simple way to represent a 3D object, which has been directly upsampled based on CNN structure. However, due to the intrinsic irregularity of point cloud, its results need to be reconstructed to mesh and makes their results severe noise and lack of detail. Recently, some preliminary investigations have aimed to enhance the surface quality by representing 3D surface in 2D domain using normals mostly in the field of physical cloth enhancement. This kind of strategy can avoid a high computational complexity, which has also benefited from well-developed 2D image SR techniques. However, these existing methods in 2D domain usually only explore a single modality, which is lack of utilizing the multimodal attributes of 3D objects to further improve the performance of upsampling. For comparison of the above methods, we choose to carry out the 3D surface super resolution problem in the 2D normal domain. Then we introduce multimodal information to improve the effectiveness of our super resolution network. Finally, we collected a new dataset for the training of the network. More specifically, first, we obtain texture, depth, and normal data from LR 3D surface. Then, these modality inputs are fed to our MNSRNet to generate a high-resolution normal map. Finally, the SR 3D object surface is reconstructed by the enhanced normal map. Here is the architecture of our MNSRNet. Firstly, we propose the MPS to reduce the data distribution differences of three input modalities. It extracts several special side modality features which can be fused to the main modality easier. Next, we propose a cross-modality transformer structure to align from the side modality features generated by the MPS and extract intermediate features represents the deep texture and shape information of the surface. After that, using the cross-modality affine fusion groups, the extracted intermediate features are fused into the main modality to assist the target SR feature representation. In this module, inspired by the spatial feature transform mechanism, we fuse the extracted texture and shape features into the backbone of the SR network step by step. Finally, the resulted features will be fed into our upscale module, which contains an upsampling block and a vector normalization layer. Our network is trained by optimized the loss function of the weighted summary of the following pixel loss and normal angle loss. Currently, the most widely used photometric stereo datasets such as Diligent and Ground and Apple dataset do not have enough images for the multimodal SR training. Therefore, we have established a new photometric stereo dataset, namely WPS, for multimodal training. WPS contains 400 different objects up to the resolution of 1000 × 1000. Each object is captured under 18 predefined lighting conditions. Our dataset can be downloaded in the link above. Here are quantitative comparisons with 9 representative methods. And here are some visual comparisons in model from our WPS dataset. Here are more visual results. As you can see from these results, our method generated the sharpest edges and restores the best details. In summary, our contributions can be summarized as, we enhance the 3D surfaces using multimodal super resolution methods in the 2D normal domain. We propose a novel multimodal-driven surface super resolution network. We established a new photometric stereo dataset for multimodal training. And the experimental results demonstrate that the proposed method delivers promising surface geometry details compared with 9 competitive schemes. Thanks for listening. More information about this project can be found in our paper. Hope you enjoy our work.